Hi there. Welcome to section 1-8. Kind of a random section thrown in here, but we're going to just interpret some graphs of functions. Now that we've been talking about functions, remember functions, f of x equals, it passes the vertical line test. If you think way back, throw back to chapter 1. So our objective is to look at intercept, symmetry, positive and negative, increasing, decreasing, relative max and mins, different things like that. So first thing we should mention is intercepts, which everybody knows already. The points where the graph intersects the axis. And of course, the x-intercept is where the graph touches the x-axis. The y-intercept is the point at which the graph touches the y-axis. We all know what they are, where to find them, and we've worked on interpreting what does that mean in each situation. So really quickly, we didn't mention this, but I know that you can figure this out pretty quickly. 1 and 2, it asks you to identify the functions as linear or nonlinear, estimate and interpret the intercepts. So, number 1, linear or nonlinear. I think we all know that is nonlinear because it's not a line. Number 2, I think that we all know, right? This one is linear. Easy peasy. Estimate and interpret the intercepts. So this number 1 is nice and neat marked for you. So in this particular graph, which is just quadrant 1, so we use the piece of graph that we're given. So the x-intercept is going to be on the x-axis. So right about there. If we're going to name the x-intercept is about at what, 7.2 or something like that. 7 point something, just a little bit past 7. The y-intercept is over on the y-axis, and that looks like it's at about 15. Now on a quiz or something, if you told me it was 16, I certainly wouldn't argue with you. It's somewhere around there. So what does that mean? What does the x-intercept and the y-intercept mean? It usually is easier to talk about the y-intercept. What does it mean if the y-intercept is 15? So if you look at the graph itself, it's called the height of a launched object. Launched means that we're going to somehow blast it into the air, throw it, rocket, whatever. And the x-axis is the time in seconds. The y-axis is the height in meters. So what does a y-intercept of 15 mean? That's where it started, right? It started at 0 time. It started at 15 meters. What does the x-intercept mean? The x-intercept is where your x-axis is, or the graph intersects your x-axis. If that's at 7.2, notice what's the height at 7.2 seconds? 0, right? So that's the time it took to fall down. How about that? To fall down. To hit the earth again, to come back, to drop to 0 height. Number 2, notice we do have an x and a y-axis. You have to look for them. Look for the arrows if that helps you. So the x-axis, or x-intercept to me looks like it's right there at 1. And the y-intercept is right down there at -5. What do those mean? Controlled thaw of a sample is the title, and the time in hours is the x-axis, and the temperature in degrees Celsius is the y-axis. So y-intercept, again, usually the easiest to start with because that's when your x is 0 or our time is 0. So doesn't that tell us that our sample started at -5 degrees? Notice how in both of these I said started at, because that's when our time is 0. The x-intercept is 1. So if the x-intercept is 1, that means our y value is 0, right? So it took 1 hour to get to 0 degrees Celsius. Everybody knows those x and y axes. So now let's talk about some other stuff. So I've got a table for you. First thing we should talk about, positive and negative. I put a little graph on there. Feel free to highlight or whatever. A positive graph is just where you're above the x-axis, and the negative part of the graph is below the x-axis. Don't confuse that with the increasing and the decreasing. Increasing is just like it sounds like when we think about slope, it's increasing. Increasing, the graph is going up, and decreasing, the graph is falling. So if you look at those two pictures and the difference between them, here's my positive. The graph is above the x-axis. And here's my increasing. Increasing doesn't matter where the x-axis is, it just means that the graph is coming back up. And we always read it from from left to right like we usually read. So we look at that graph falling for the first part, going back up, and then coming back down. Extrema are high or low points on our graph. Sometimes you have only high points, sometimes you have more than one high point. Sometimes you'll have only a low point or more than one low point. So a relative minimum, or min, I call it a relative min, is a low point on the graph. It might not be the lowest point because an arrow might point yourself further down. So if you notice in this little shape down here, this arrow tells you that this graph keeps getting lower, but this point right here, point A, is the lowest point relative to the other parts around it. A relative maximum is a high point or points. Notice this arrow over here on the left tells you that it keeps going up, but point B is the highest point where it switches directions. So really you could think of a relative min or a relative max as a switch in direction, and what is that highest or lowest point before it changes and goes the other way. And last but not least, when we talk about end behavior, for right now, we're just going to explain the graph and use the labels. Notice in this example, in this table, I didn't have labels like degrees Celsius and time in hours. So all I could say is the graph is decreasing, and then it increases, and then as you move right, the graph goes down. And as you get into more algebra, we'll talk about end behavior more specifically, but really we're going to just explain the graph. So here's what the work is going to ask you to do. And let's talk about problem number 3. It says to identify the graph as linear or nonlinear, estimate and interpret the intercepts, symmetry, and we didn't really talk about symmetry, I'm not worried about that, where the function is positive, negative, increasing, decreasing, x coordinates of any relative extrema, and please make that x coordinate into a y coordinate of any extrema. I don't know what I was thinking. Then describe the graph, talk about the behavior of the graph. So in problem number 3, the deer population. First of all, is this linear or non? Nonlinear. Tell me about the x-intercept. Notice it only gives us quadrant 1, so we're just going to use that as our information. So the x-intercept on the x-axis looks like it's about 5.5 to me. The y-intercept on the y-axis looks like it's about, I don't know, what would that be, 60, 75 or so? 72. Again, if you're somewhere in that range, it's not the end of the world, but it's somewhere almost 80, but it's got to be bigger than 60, bigger than 70. Notice it's counting by 20s on the graph, on the y-axis, but only labeling by 40s. What do those intercepts mean? The y-intercept, that's 75. Notice the graph title, the graph is deer population. The x-axis is time in years, and the number of deers are y-axis label. So y-intercept, if it's 75, tells me, remember I used the word starts at, so the deer population starts at 75 deer. The x-intercept tells us the value of x when y is 0. So what does that 5.5 tell us? There are 0 deer after 5.5 years. It's kind of a sad graph. Looks to me like the deer population died out. Is that what it looks like to you? Symmetry, let's skip that one. where the function is positive or negative. So these two guys go together. So positive graph, I'm going to have to scooch this up a little so I have some more room to write. These take up a little bit of space. Positive graph, right, is where it's going up, or it's where it's above the x-axis. Everything's above the x-axis, right? So I would just say all. The increasing and decreasing, because here's our x-axis, by the way. So everything is above it. Can we get into negative, dear? Probably not, so takes care of that. Increasing and decreasing, however, I do have information for. So if we start with increasing, it looks to me like right here up to here, the population was increasing, right? So it was increasing from how many years to how many years? 1 year to 4 years. Where was it decreasing? Decreasing from 0 to 1 year right here. 1 year. And then when else did it start decreasing? At 4 years, the population started decreasing. 4 to 5.5 years where it actually hit 0, and then there is no more. So we've got 2 decreasing parts and 1 where that deer population was increasing. And last but not, well, the extrema. So the relative max and relative mins. I see one of each. And remember, it's kind of like a change in direction. So right here, I see a point where the change in direction happens. Is that a relative max or a relative min? Is that a highest or a lowest point relative to the others? Low, right? So relative minimum or min. And the y value, when I hit that lowest point, I know it's at 1 year, but how many deer were there? Looks to be about 60 deer. And then the population started increasing. Relative maximum is when it hits a highest point and then it changes. So right here looks to me to be a relative maximum. 4 years, how many deer were there for that relative maximum? I'd say about 130 deer. And last but not least, it says to describe the graph. So let's describe the graph. And we kind of did when we talked about the increasing and decreasing. So here's how I would describe the graph. I would say the deer population decreased from 0 to 1 year, decreased to 60 deer, and then it started increasing and went up to 130 deer. And then the population started falling again and hit 0 deer at the year 5.5, 5.5 years. So there's my description. And I know people don't like that part because there's a lot of writing, but you've really looked at the graph and picked all that information out already. So you already know what that looks like. Do we need to talk through another one, or maybe we could just work on some? I've got a lot more examples here for us. Notice example number 4, practice number 4, is that one linear or nonlinear? That one's linear, right? Here's the thing. I have an x-intercept. I have a y-intercept. Do I have positive and negative? Positive is above the x-axis. So here's where it's positive. So I would say from 4 weeks on, it's positive. Below the x-axis, it's negative. So I would say it's negative from 0 weeks to 4 weeks. So this is my negative because it's below the x-axis. Increasing and decreasing looks to me like it's only increasing. Isn't that what it looks like to you? Since it's linear, we're only going up. There is no change in direction, so it's increasing only. Increasing only. Any extrema, any relative maxes and relative mins? Well, that's the interesting part because, I mean, really, our only relative max or min, this would be a relative min at 0 weeks, the profit was negative $400. So negative 400 would be my Y value of that. My relative max would be right here at, what is that, 12 weeks. It would be about $700. So $700 would be my max, and negative 400 would be my min. That's really all I've got. And then describe the graph, we could say, as the weeks go by, the profit started at negative 400 but went up to $700 after 12 weeks. So that would be my description. All right, look good to everybody. I've got a couple more examples here, but I think you're probably good with just looking at those and working on them. So we'll talk about these and we'll do some of these kinds of problems. That is it for section 1-8.